Dobro jutro. Ja sam Christopher Penn, and that is the extent of my Serbian. I apologize, I'm American. Today we're going to talk about exploratory data analysis and why it matters for artificial intelligence. Just a show of hands, please. How many of you right now are developing using artificial intelligence? Okay, keep your hands up. How many of you are doing so in partnership with a data scientist? Where'd all the hands go? Okay. That right there emphasizes artificial intelligence's biggest problem right now. Couple of stories. In 2018, Amazon developed this hiring system using artificial intelligence. It would take in resumes and CVs and try to predict who would be a good candidate. The moment they turned it on, it stopped hiring women. Just stopped. Because the data set that they fed it to train on was almost exclusively male. Nobody there asked the question, what could go wrong? And clearly, a lot of things did. Another example from 2019, at the the MarTech conference, this vendor was showing a predictive algorithm for a company to try to show you where your ideal customers were. And they were using the coffee brand Dunkin' Donuts. And they brought up a schematic of the city of Boston in the USA. Now, Boston in the USA is a very diverse area. There are certain sections of the city that are predominantly minority. There are certain sections that are predominantly wealthy, etc. And they brought up this lovely map. The red dots show where they think your ideal customers would be, and the black dots show where your ideal customers would not be. Now, this coffee brand in the USA it's a very cheap coffee, right? The only people who don't drink it in Boston are dead, right? Everybody drinks this brand. And yet, what it came up with was only the wealthy majority areas had ideal customers. All of the black dots are all predominantly minority areas. They essentially reinvented a technique that is illegal in the USA called redlining, where you simply take a map and draw red lines around the city that you don't want to do business in. That's illegal. And yet nobody thought to ask, hey, with this data, what could go wrong? The reason why is there's an awful lot of people who are working in AI right now who are trying to build something as fast as they can to see if they can, and nobody's asking, is this a good idea? From the movie Jurassic Park, your scientists were so preoccupied with whether or not they could that they didn't stop to think if they should. And this is why artificial intelligence is having such a hard time being adopted by companies. In the 2021 CMO survey, chief marketing officers, when asked, said, how many of you are currently using artificial intelligence or machine learning in your companies? It's only around 12%. Now, this is technology that, if you use it well, can dramatically increase your revenue, can dramatically improve the efficiency of your business, and yet only 12% of companies have managed to do this, partly because you have all of these deployments that are going very badly. Why? Why does this happen? A couple of reasons. One, we tend to think of AI as this collection of extremely complicated technology, very expensive stuff, and it doesn't have to be. But two, it's because we don't understand what it is. Artificial intelligence is really nothing more than an appliance, if you will, right? Just the way a spreadsheet is a collection of techniques put together, just the way a word processor is a collection of techniques put together, AI is no different. The trouble is that there's a lot of people developing AI, pushing for its adoption, who don't understand what it's good at, who don't understand how the thing works. They don't understand the purpose of it. They don't understand the techniques, the mechanics of how to make AI work. They don't understand the process and the order of operations. But most of all, they don't understand the ingredients going into it. If you were to assume that artificial intelligence was kind of like cooking, then data is to AI as ingredients are to cooking. For those of you who are not doing machine learning development yet, all machine learning is, all artificial intelligence is instead of us writing code, we give machines a big pile of data and say, write your own code. find either predictions, find classifications, or make something. And that's all it is. For folks who have been trying out the generative AI, like DALL-E 2, Midjourney, these things that create these fantastical images or text generation, all it is just a piece of software that predicts based on inputs given to it. So how do we fix this problem? How do we prevent systems from not doing what they're supposed to do? It's through a process called exploratory data analysis. Right? This is a critical part, and it's a part that pretty much everybody who's developing AI too fast skips over. What is exploratory data analysis? It is the main purpose of exploratory data analysis is to look at data before making assumptions. Right? It's to look at data before making assumptions. Put it in cooking analogies. One of the things that people tend to do is they have an outcome in mind before they start looking at the data. Right? Imagine you're going to make dinner and you say, guess what? I'm going to make steak tonight. You have this assumption. I'm going to make steak. And then you open your refrigerator and there's no beef in there. Right? Are you having steak tonight? No. Had you looked in the refrigerator first, you might have seen that you had enough to make, a decent chicken noodle soup. But there's no steak in there. There's no beef in there. So you can't make what you want. But that's the trouble with AI. A lot of people have this predefined outcome in their heads that says, I'm going to do this thing and it's going to do this. They make an assumption before they look at the data. Why do people skip it? Because we want steak. Right? The number of executives that I hear say, we're going to put artificial intelligence into our software, we're going to make our product AI enabled, is staggering. And most of these people have no idea what they're doing when they say this. They just say, we're going to call it an AI enabled software just so we can say it is. There are a legion of problems in the world that AI is really bad at solving. Right? AI is bad at solving problems where you don't have enough data. AI is bad at solving problems where you have a computationally simple solution. Right? There's so many things that AI is a bad match for, but a lot of people, particularly in the corner offices of the world, seem to think that if they slap AI on it, people will buy it. So how do we do this? How do we do this? Well, again, it's like looking in your refrigerator to see what's in there. What things do you have to work with? What kinds of data? And that's what the exploratory data analysis lifecycle is. It's just a process of looking in your fridge, looking in your pantry, looking to see what data you have, and then deciding how the product's going to turn out. So the first step is pretty simple, your goal and your strategy. What are you going to do? What are you trying to do? And the easiest way to get people to be clear about this, so you can even tell whether AI is a good solution or not, is to have the stakeholders come up with user stories. How many people here, developers, use user stories? Okay, there should be more hands up, but okay. If you're unfamiliar, this is a user story. As whatever your role is, I need to perform some task so that I get some outcome. So, for example, as a developer, I need to know what makes digital marketing articles do well so that I can create a content marketing service. Right? Every project that you work on, particularly in AI, needs to have a user story clearly defined so that the people who are going to do the coding, the people who are going to do the data analysis, can look at everything that happens after it and say, does it tie back to this or not? One of the things that happens with AI projects is that an awful lot of the time, we tend to scope creep. We tend to start adding more and more features that really don't belong because this is not clearly defined. The second step is data collection. Where are we going to get our data? With any kind of project like this, you need to have data of some kind from somewhere, and how are you going to get it? For example, if we were going to build this content marketing service, we might have to use SEO tools. This is an example of one called Ahrefs from the marketing industry, and they provide a whole bunch of data from their API. But you have to know the landscape of the data that you're trying to bring in to build an effective machine learning model, and you do need a lot of it. You need at least thousands, if not millions, of data points. If you don't have that, it's at this point where you'd say, okay, we need to stop and either refine the user story to find a data source that has enough data, Or we proceed with the understanding we're not going to be using machine learning because there isn't enough information to work with. So where does your data live? Who has it? There are some companies that have enough data to make decisions, but unfortunately, that data is stored in organizational silos. We worked with this one company that, bizarrely, their sales team would not share data with their marketing team. So their marketing team was like, we want to build an app to help you develop better sales leads. And sales is like, we're not going to give you any sales data. And I sat there and said, what's wrong with you that your sales team is unwilling to share data? It turns out that their sales team was so bad at sales that they could not show that data or they would all be fired. They went out of business, so, oh well. The third step is attribute classification. So what's in there, right? What does the raw data look like? When you get this data from the different sources, what shape is it in, right? So this is an example of the two languages that you're probably going to be working in for machine learning are either going to be Python or R. You can do other languages like Julia, but only really nerdy folks use Julia. But mostly Python and R. This was R because I'm old and I can't do Python. We look at the data and we say, what's in here? What are the characteristics of it? What are the different data types? And again, you would think this is something that's straightforward, but a lot of the time, particularly when you're working with real-world data, it gets super messy. There's all sorts of bizarre distortions in it. So using I forget how many different exploratory libraries there are, but there's at least 24 in R and several dozen more in Python. You can examine your data and say, what condition is it in? Just from a data analysis perspective, what's missing? This data set has 16% of its data missing, right? So it's not necessarily the cleanest and healthiest data set. We've got 39% just non-numeric columns. We've got 61% numeric columns. Just looking at the data and then going back to your user story and saying, does this look like what we expected it to look like? Again, looking at the data types. What are all the different formats that are in here? And are they correct? Some of these are not. Some of these, there's some issues with them. Things like URLs really should be separately typed. When you look at the data, you can then take your user story and say, you might have to refine it. Right? We said, as a developer, I need to know what makes digital marketing articles do well. Well, do well is kind of amorphous. It's not really well defined in here. So the question is, what constitutes doing well? This, because you have the user story, you can now go back to the stakeholders and say, what exactly in this suggests doing well? And we would say, in this case, traffic. Like the number of people who actually see this thing would be an indicator it's doing well. So we refine our user story to say, as a developer, I need to know what makes digital marketing articles earn traffic so that I can create a content marketing service. That refinement now helps you, as a technologist, do a better implementation and helps the stakeholder understand, okay, I know what I'm going to get. Our fourth step is looking at the initial analysis. 4 different types: univariate, multivariate, quality checks, and anomaly detection. How good is the data? How good, and what condition is it in? We have just some columns here that are not in great condition. 70% of these have bad data in them. And then we have some columns which are missing so much data that it's not even worth keeping them. Part of data science, part of the exploratory data analysis process is knowing when you've got garbage, right? When you have things that don't make sense. And you're going to have to partner with domain experts, because one of the challenges with machine learning is that often engineering is separate from domain expertise. And we create something, and then we hand it off, and there's this assumption that as the engineering was done right, without the input of domain experts. And the domain experts would be the first to say, no, you don't need this. Like, you don't need the republished data, or you probably don't need the platform, or yeah, we do need platform, and it's missing. In which case, we know we've got a bad data set. We need to go somewhere else for it. But if you don't have that partnership, this will not work. The easiest way to have that partnership, to create that partnership, is beer. If you, as technologists, partner with domain experts and say, hey, we need to talk this over. Let's grab some time on Friday at 3. I'll bring beer. Let's talk about what you want and what we know from the data. You can then start to refine it. You can start to improve on the data. You can look at distributions and say, well, this data set that you've handed us, there's an awful lot of weird distributions. There's an awful lot of things where there's just not a whole lot to see. And the domain expert could say, okay, that's fine. Some of these things, it's not a big deal. And some of these things, that is a big deal. It's going to be hard to predict. You look at traffic. This is our outcome. Most of our data here shows that we don't have any traffic, so it's going to be kind of hard to build this outcome. So that's univariate distribution. You can do bivariate distribution, multivariate distribution, all these fun mathematical tricks. What we want to look at, though, is do we have enough data to work with? What's missing? Right? Is everything else complete? Do the numbers make sense? In this data set, there's some wildly varying numbers. There's some numbers where the mean is single digits and some where the mean is absurdly large numbers. Right? Building a model based on data that looks like this is going to be really hard. But you need to do this analysis. Again, one of the things that tends to happen is that we as engineers will get a data set from somebody else and start coding, start building an algorithm without doing this step and saying back to the folks who provide the data, this data stinks. Right? It's like opening up your refrigerator and finding out that all the food is rotten, and yet someone expects you to cook with it. Right? There's also stuff in the data that you might want to look at that you'd have to engineer. So for example, we're talking about building a content marketing service. What are the words and phrases that are in there? You might want to pull that out and say, does this even look correct? So this is an example where we did natural language processing, did some bigram analysis, which is 2-word phrases, and said, what's in here? Well, a lot of this text that's in here is actually software reviews. If we're trying to predict what would make a good piece of content marketing, this might be helpful, or it might tell us that there's something wrong with the data, that we've actually accidentally just ingested a bunch of reviews, and that's not going to be super helpful for creating a service that predicts what's going to work, because it's probably going to think that you just need to have a bunch of review sites. The next step is requirements verification. Does the data we have answer the question? Right, we go back to our user story. As a developer, I need to know what makes digital marketing articles earn traffic so that I can create a content marketing service. Does the data that we've seen so far answer this question? Yes-ish. It needs some additional work, but there's enough to work with. It's like saying, is there enough in the refrigerator to make steak? Like, okay, we found some beef. We're missing a few other things, but at least we found that there is beef and it's not rotten, so we can do that thing. Next, the preparation of the data. How can we get this data ready for usage? Again, looking at the characteristics of it. What are the things we can get rid of? We know we can get rid of this because it's just missing. We know we can get rid of this. But there's these other characteristics that with the help of the domain experts as well as our analysis, we can say, yeah, we've got to get rid of some of this stuff. The HTTP code, that's entirely the same. That has no predictive power whatsoever. Let's get rid of it. The language, so much of it is missing, or just one language. It's not helpful. It's not going to be predictive. The platform is filled with missing variables. Some of these things you will have to ask a domain expert about, to say, like, does referring domains matter? What does that mean? Does domain rating matter? What does that mean? In your data set, as you're building your models, you will have to ask a domain expert, how important is this from a macro perspective for the kind of outcome we're looking for? Because sometimes there may be things that don't matter at all, but they look important, right? We might think, if we don't know how the web works, we might think the HTTP code matters because it looks good, it looks numeric, it looks okay, but it's not helpful. So again, that partnership with domain experts is really important. Next step in the process is feature engineering. What do we need and what can we get rid of? In all of our data, there's stuff that can be unlocked, that can be expanded. For example, take a date, right? Today is what? November 3rd, 2022. You have a month, a day, a year, but you also have the day of the week, the day of the month, the day of the quarter, the month of the year. You have the number of the day of the year. So you can expand this data and turn it into much larger sets. If you're doing natural language processing, like we saw in software reviews, we might want to say our top 5 categories, we might want to turn those into variables themselves. And this is relatively straightforward stuff. Again, if you are a coder, you can actually laugh at my code because it's not very good. I still struggle with error checking. But we can take apart our data and expand it out and grow it to make some things larger. And other things we might have to collapse because there's just too much variability for it to be useful. In a list of URLs, we have 12,000 unique URLs. You could build a model on that, but it's going to take you a couple of months. It's going to chew up an awful lot of compute time, and it's probably not going to be all that helpful for predicting that content marketing service. If, however, you were to say, instead of those overall URLs, what if we just flattened it out to just top-level domains? Now there's only 260 of those. We can build a model with that. So again, feature engineering is about taking out stuff we don't need, expanding stuff that we might find helpful, and collapsing stuff where it doesn't make sense. We might want to do things like feature ranking, where we'd say, let's take a look at the estimated importance of all these different features. Does day of the week matter? That's a testable thing. We can do a regression analysis to figure out, is that important? Is week of the year important? Is domain important? All these things can be tested and should be tested before we start building our model. Again, this is a very simple Spearman correlation. If it's in this middle band here where there's not really any statistical relevance, these are things that probably are not going to be predictively useful. The length, it is starting to be predictively useful. Like the longer URL is, the less helpful it is. Our traffic is our target variable. Referring domains shows a good relationship. So again, doing this testing on our data first before we ever start to build a model will help us understand what stuff can stay and what stuff has to go. And then finally, we can build the model. We can create this thing. What is the results? What does it look like when we build this model? It turns out that referring domains followed by URL length are the 2 factors that we can make a determination will create a valuable content marketing service for us, that we can create software predicting on these variables. If we had not run these tests, if we had not done our exploratory data analysis, we would naively assume everything mattered the same, and we would create software that would have no predictive power. And we would offer this to the market. People would use it and say, this thing delivers terrible results. I don't want to buy it again. And then we all go home feeling very unhappy. But when we do exploratory data analysis correctly, we figure out what matters and we clean it up. So if you are considering starting to do modeling with artificial intelligence, with machine learning, this is the part that has to be part of the process. Let's go back. Does this meet? Does this answer our question? As a developer, I need to know what makes digital marketing articles earn traffic so that I can create a content marketing service. And we did. We know what earns traffic so that we can create this service. So how do we get started with exploratory data analysis? Obviously, you have to do the process itself and learn the steps of the process, or partner with somebody who has data science capabilities. Right? Data science capabilities, data science, all it really is applying the scientific method to data. That's what we just walked through, this example of how to apply this to data. There are a lot of companies, I'll offer this caution, there are a lot of companies right now that are offering supposedly automated ways of doing this. Right? They have automated data prep services, which is kind of like, pre-cut vegetables. Those are okay, but a lot of them have some issues because they are making assumptions of your data that you may not necessarily want to have those assumptions made. Or worse, you have automated machine learning services where now you have almost no say in the matter. You have no say in what's in the box. Right? That's one of the biggest challenges. There's a reason why we walked through this process step by step manually, why it is so detailed, because you want to have control over this. Now, when it comes to machine learning and AI, if you are building something, or if you're considering the use of machine learning for just additive benefits, right? Little incremental improvements in your company's products and services, then yeah, you can use a boxed product, right? This is totally fine if it's not going to be part of your secret sauce. But literally, if machine learning is going to be part of your secret sauce, you want to do this yourself. You don't want to leave it up to other vendors. You especially don't want to turn it over to a vendor who then holds you hostage, right? As much as we like services like AWS and Google Cloud and Azure, if a vendor controls the infrastructure and the model that your core competency is based on, you are hostage to that vendor. You cannot leave them, and that's kind of what they're counting on. So as much as possible, if you're building for your secret sauce, if you're building in your core competency, you want to own as much of it as possible. Here's the important part, the people. The people who make up effective data science and effective machine learning teams. There's 6 of them. Most of the folks in this room probably fit in the coder category or the data engineering category. Right? Those are essential skills. You have to be able to code. You have to be able to create and the machinery that runs machine learning. You have to be able to know your data systems. You have to know where your data is stored, how to get it in and out of things. But those 2 roles aren't enough, not if you want to do machine learning well. You need to have somebody who has a scientific mindset, who knows the scientific method, who can walk through each of these steps in this process and say, we're doing a good job with this, or we're not doing a good job with this. Right? We've skipped some steps, or we're on track. You need to have somebody who has statistical expertise. Right? That is almost non-negotiable, because all machine learning really is a bunch of probabilities. Right? Machine learning is really nothing more than probability. It just sounds better. The number of AI projects where there isn't somebody who has statistical expertise on staff is probably the vast majority, because no one's looking at the numbers underneath the code. They would just kind of run the code and hope that it all works. Or worse, we use somebody else's model assuming that it's all correct. Well, as we saw at the very beginning of the talk, that's not the case. When you get a model from someone else that you can then fine-tune, you don't know what's in that box. So relying on it for your core competency, relying on it for the heart of your product, would be a very, very bad idea without somebody with statistical expertise, mathematical expertise, to say, yes, this is a good idea. In marketing, for example, we have this one set of techniques called attribution analysis. What in marketing is working? Is Twitter working? Are Facebook ads working? Is it Google ads working? Most attribution models that are available in the marketplace today, when you dig into the math underneath them, they have very specific use cases. But because there's nobody who has stats and math expertise, the people who are using the software aren't sure what to do with it, and they make bad decisions. So you want to make sure you have that capability. The other 2 expertises is business expertise. Again, if you're building a product, you want to have access to somebody who can say, yes, there is a demand for this. I have a tendency to build projects out of habit and fun that don't have any commercial use whatsoever. I just build them because I'm a nerd and I have no life. I built a tool the other day to look at playlists in Danish and try to guess what the most popular birthday songs are on the playlist, because I don't speak Danish any more than I speak Serbian. And it worked. I built a nice model for it, and I showed it to my business partner, who said, this is cool. This has 0 practical application. There's literally nobody in the world other than you that wants this thing. So having that business expert is really helpful. And finally, the domain expert, that's somebody who knows the model you're trying to build. This is where, again, you can run into a lot of very dangerous behaviors when it comes to machine learning. Early in the pandemic, there was this one person who's fairly well known in the machine learning world who said, hey, let's try to use machine learning to guess which of all the available therapeutics available might have an impact on COVID. And they all, this whole group of like 160,000 people, all grabbed a bunch of pharmaceuticals and tried to build a predictive model. And they came up with an answer, and they ran it out to the press and got people talking about it. And once the clinical trials actually happened, it was found that this AI-based model that somebody built had no predictive power whatsoever. It predicted a treatment that had 0 practical effect on COVID. Why? Because there wasn't somebody with domain expertise who was looking at what these engineers were doing and saying, guys, this is really dumb. This is, we know this particular class of drugs has no impact on viral diseases of any kind. So whatever those folks built with their model, it was ineffective. Even though it made sense from a statistical perspective, it made sense from a code perspective, it did, the process passed some of the scientific method, but because there was no domain expert, things went off the rails, and they were making very, very bad predictions. So, the purpose of EDA is to look at data before making any assumptions. Right now, in the United States, we are doing, our government just floated this idea of an AI Bill of Rights. Not for machines to have rights, but for what we as technologists do with these models, people should have rights around them. In the same way that, for example, in the EU, there's the regulation, the General Data Protection Regulation, GDPR, that says these are your rights when it comes to data. These laws would not exist if we had done this, right? If we had looked at the data and we'd asked ourselves, going through each of these steps, is this a good idea? Does the data support this? How we're using data? In marketing, which is the domain I work in the most, we collect enormous amounts of data, and we probably use maybe 1% of it. Right? We just collect ridiculous amounts of data, and we use very little of it because most marketers don't have any data capabilities whatsoever. And those companies that are using data are using it in ways that are ethically challenged. Right? Probably the most famous case is Facebook. Facebook and its scandals with Cambridge Analytica and a few other things. At no point did somebody say, hey, how could this be misused? Right? How could this technology itself go off the rails? We just saw last week a change of management at Twitter. And a whole bunch of things going on there, people forgetting to ask the question, what could go wrong? Well, it turns out a whole bunch of things can go really, really, really wrong, and no one is using this set of processes to understand that. So if there's one takeaway that I could ask you to do in all of your technology work, it is to, over and over again, at every level of your company, in every aspect, ask yourself the questions, what could go wrong? Not in a sarcastic way, but in a legitimate, unironic way. What could go wrong? How could this be misused? How could this be deployed in ways that would take advantage of people unfairly? Because right now, in artificial intelligence, we are at an important turning point. If we do not want it regulated out of existence, we have to be asking these questions ourselves. Right? No one is asking this question enough, and as a result, we're creating machines that are doing stuff with our data and doing things to us that we have no control over. Give some thought to this. How much of your life is controlled by artificial intelligence? The news you see, what you search for is mediated by artificial intelligence. Your recommendations on Netflix, what to buy on Amazon, who to even talk to. All these things are regulated by machines creating algorithms where nobody asks this question, what could go wrong? When you're building your own applications, at every stage, from the moment you get that first data set, look at it and say, what could go wrong? Is there enough diversity? Is the population you're working with fairly represented? If it's not, you have a pretty good idea of what could go wrong. Is your data in good condition or bad condition? If it's in bad condition, you know what could go wrong. When you deploy a model and it starts to drift, which means the model starts returning predictions that are inaccurate, you need to ask what could go wrong. Microsoft made this mistake in 2016. They deployed a Twitter robot called Tay. And they said, hey, this model learns. Interact with it. And within 24 hours, the internet being the internet turned into a racist porn bot. Thanks, internet. And no one at Microsoft asked the question, what could go wrong? This is the most important question in artificial intelligence, machine learning, the metaverse, Web3, you name it. Ask what could go wrong. And if there's nothing else you take away from it today, It is to constantly ask this question: what could go wrong? Thank you very much.